Section 6.1, we will be finding perpendicular bisectors. A perpendicular bisector is a line, segment, or ray that passes through the midpoint of a segment and is perpendicular to the segment. So just like the wording is saying, it's going to bisect the opposite side, and it's also going to be perpendicular. Perpendicular bisector theorem. We know that if you have a point on the perpendicular bisector, if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of that segment. So in other words, the side that it is bisecting, we know it's going to be congruent. The converse of that says if a point is equidistant from the endpoints of the segment, then we know it's also a perpendicular bisector. So two things, we're going to know that these two distances end up being equal. If this is a perpendicular bisector, it's going to bisect this side, and then you're going to form that right angle. So you're going to use that information over here to find some different things. So on this first one, it's wanting you to find EF. And so if this is a perpendicular bisector, which it is, right angle bisecting, we're going to know that this side will be equal to this side. So therefore, I'm going to plug in or set them equal to each other as an equation. And then I just solve. So I minused my 1a, I added my 15, so I got 3a equal to 27, and then I divided by 3. Always in geometry, go back and reread the question. It wants EF, so therefore to find the length of EF, I'm going to plug back in. So I'm going to do 4 times 9 and then minus 15, so my answer will be 21. Pause the video and try the check question. So in the check question, they want you to find RT. Same as before, I see a perpendicular bisector with a right angle and bisecting, so therefore RT is equal to QR. So I set those two guys equal to each other and I solved. So I minused my 2x, I added my 7, and I got x equal 5. You're not finished because you need to plug it back into RT. So therefore, when I plugged it back in, I got 13. It technically wouldn't matter which one that you plugged it back into because these are going to be equal. So even if you plugged it in that top one, you still should be getting the same answer. Now, we're still going to come over here and find some different things, but we're going to use the converse. So it's wanting us to find XY. So I notice right off the bat that these two guys are equal to each other. So the converse says that if these two are equal distance to endpoints, that means this line has to be a perpendicular bisector. Well, it is perpendicular, and that means that these two have to be equal. So therefore, XY is the same as YZ, and that's why it's 22.4. Pause the video and try the check question. So in the check question, you're going to see these two being equal to each other. So therefore, XY is a perpendicular bisector, and these two line segments have to be equal. So that is why WY ends up being 3. Okay, some vocabulary. We're going to use the words point of concurrency. So when 3 or more lines intersect at a common point, the lines are called concurrent. The point of intersection of those concurrent lines is the point of concurrency. So in other words, their intersection point is what that point of concurrency means. Okay? The point of concurrency of perpendicular bisectors is called a circumcenter. The perpendicular bisectors of a triangle intersect at a point called the circumcenter, and that is equidistant from the vertices of a triangle. Okay, so that means the distance to all of the vertices will be the same. Okay, so example number 4. Alonzo wants to install a fountain in his triangular garden. Where should Alonzo place the fountain so it is equidistant from the vertices of the garden? So if it's equidistant from the vertices, that means it wants us to find the circumcenter. The circumcenter is where you have all of those perpendicular bisectors meeting. So we're going to have to find where all of the perpendicular bisectors are. So remember what we had practiced from before. I'm going to take this horizontal line and I'm going to bisect it with my ruler. So I'm going to measure how long it is, and I see that it is, actually I can just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's going to be cut in half. So it's going to cut at 8, which is why I cut it right here. Then I'm going to take my protractor and make sure that it is 90 degrees. Well, if it's a horizontal line, it's going to be 90 degrees if it's vertical. So that's why I drew my perpendicular bisector right here through that red line. Okay. Then I came over and I bisected this side. So now I am going to use my ruler since it's a slanted line, and I'm going to use the centimeter side. So it measures about 6. So then I put my bisector at 3. Then I took my protractor, I lined up my circle on that bisecting point, and I made sure that these lines across here were flush with my side of my triangle. Now I'm going to find where that 90 degree is. So it's right here. I'm going to make a little mark, and then I'm going to draw in my perpendicular line, which is what you see that red line being. Okay, so where those two intersect is your circumcenter. So this spot right here, roughly, is where my circumcenter should be. So my coordinates of my answer would be at 0, 4. So I start at the origin, I don't move any left to right, and I go straight up 4. Pause the video and try the check question. So in the check question, you should have done the exact same thing. So here you have another horizontal line. So bisect it. It's going to be perpendicular, vertical line right through there. I went ahead and I bisected this side over here. So I measured with my ruler. It was about 4. So I bisected it at 2 or 2.1. Then I took my protractor and I lined up my circle. I made sure that my lines here were flush along my line. And I made a mark where I have my 90 degrees for my 90 degree angle. And then I drew in that line from my bisector so that I can draw in my perpendicular bisector. Where those two intersect is where my answer are. So starting from the origin, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So that's why I said 7, 4 for that answer. All right, so perpendicular bisectors, a lot of vocabulary, making sure you know what they look like on a triangle, also knowing that their point of concurrency is called a circumcenter.